Friends, welcome to Truth of Physics. Today we'll discuss how you can find the eigenvalue and eigenvector of a given matrix in Python using numpy. तो पहले मैं एक 2x2 easy एक मैट्रिक्स ले लेता हूँ. Suppose we have a matrix like this 1 4 3 2. So if you find the eigenvalue of this matrix like 1 minus lambda, 2 minus lambda, 4 and 3, this determinant is equals to 0, then we will find the lambda to be equals to two values 5 and minus 2, 5 and minus 2. And if you find the eigenvector of corresponding 5, eigenvalue 5, then we'll find it is something like 0.707 and 0.707. And for this eigenvalue, we'll get the eigenvector to be like this 0.8 and minus 0.6, or vice versa, means the minus can be here and this can be plus also. So let us try how we can find this numerically using Python. Okay, then we'll use in Jupyter notebook, and we are importing numpy as np. तो अब हमें क्या करना पड़ेगा? First we have to form the matrix. So how we can form a matrix? I have made a video previously. You can watch that. The link I will give in description box. There I have discussed how you can form a matrix in Python numpy, using numpy, and also how you can find the each elements, or how you can slice the matrix elements. So for forming a matrix, you have to do something like this. We are doing here a 2x2 matrix. Suppose a comma b comma a comma b. This is the first row, and this is the second row, c comma d. And this is a two-dimensional 2x2 matrix, so this will form a 2x2 matrix. Like we can define a function and put values according to our interest in that. Like define some Hamiltonian, suppose, or some matrix a comma b comma c comma d, or you can just put 1 4 3 2, like we have discussed here, these values here also. So I am doing the more general thing here. Okay, so yes, so just plugging this here, and then we have to now do the thing that eigenvalue we are denoting. I am denoting with eval, and eigenvector with e vector equals to np dot linalg dot eig, means eigenvalue of the given matrix A. Now here one more thing to note, that if we have given a symmetric matrix, then the more appropriate one you can obviously use this thing, but for getting more accurate result, according to the Python library, Python documentation, I found that you can use also this thing, np.linalg dot eigh. Okay, so this is for symmetric matrix. Return eval e vector. Then suppose we are printing Hamiltonian. What was that? 1 4 3 2, 1 comma 4, this is the first row, and then 3 comma 2, right? That we have discussed here, 1 4 3 2. If we do this, then what we'll get? Then we first object, this is the first object, right? This is the first object, which is nothing but the eigenvalue, and this is a 1D array. You can see this is an 1D array which contains the two eigenvalues. The first one is -2, and the other one is 5 that we have discussed here, 5 and 2, right? So, and this array, the second object, is a multidimensional array which contains the eigenvectors, and you can see that the eigenvectors are given or arranged column wise, right, vertically. This is -0.8, 6. This is this eigenvector, right, minus 0.8, 6 and 6, and this is 0.7.7. This minus sign is not a problem. Here we can also write this as minus signs, with minus signs. So now if we want to print the each elements, like the eigenvalue 2 and its corresponding eigenvector as a column vector, then what we'll do, we have to use array slicing. And the previous video that I made on multidimensional array slicing in using numpy would be helpful if you don't know previously. So how can you do that? Hamiltonian and 1, 4, 3, 2. Now we are just we want to what? The first object, this have two objects, right? This will return two objects. This is the first object, this is the, and this is the first object, eigenvalue, and this is the eigenvector. So we want to first identify the eigenvalue. So this is the 0th object. This first part will denote the what we are supposed to identify, supposed to do. So this is that, and the second part, this thing, this third bracket, will help you to identify which element. If you want to find the first eigenvalue like -2, then you have to put just here 0, and let's see what happens. So this will give -2, this eigenvalue. And if you put here 1, then it will give the second eigenvalue, right? So I'm just finding the first. So, and let's calculate its corresponding the eigenvector of the eigenvalue -2. And how we can do that? Okay, now this is the second element, right? Second element. So that we have to do here 1, right? This indicates that we are calculating now, or we want to show that eigenvector. Now this thing, we want to show the first column means all the rows. This means this symbol means all the rows, keep all the rows intact, means this row, and this row, and only the first column, or the first column elements, means the 0th column. So it will give you what? This array, right? -0.8, and you can find that -2 eigenvalue has eigenvectors this -0.8 and 6. So -0.8 and 6, which is perfectly fine. Now if you do here the 1, then you will get the second eigenvector, which is corresponding to the second eigenvalue like 1. So in this way you can find very easily eigenvalue and eigenvector, and print the respective eigenvalue and eigenvectors of any given matrix using numpy of Python. So hope this video is helpful. Share this video with your friends, and keep watching my videos. So thanks for watching.